Hello guys and welcome back. So basically we are back with day 5 of the 100-day JEE Advanced question series. So basically this will be the question for today, and this is a really interesting question. Okay, one of a kind. I have not seen a question of this type even before. Like, this question is based on 3D geometry and conics. You can say it's a question based on conics in 3D geometry, like that. Okay. So this is something actually that I know most of you might have not encountered before, and this is an idea that JEE Advanced is still pending to give. Okay. This is nothing, let me tell you, this is nothing out of your syllabus, because whatever we are going to use in this problem, it is absolutely inside your syllabus. And this is some idea that JEE Advanced hasn't copied still, or rather not copied, I should say. They haven't introduced still in any paper. Okay, so maybe you can expect this in future. So guys, you can try this question out if you want. I will wait for a few seconds and then start on with the solving. So okay, I guess now we can start off. So for that, first thing, I will read the question. So we have to let AB be the shortest possible distance in between two given lines denoted by L1 and L2. Okay, so shortest possible distance. That means L1, like, I will read the question and write down the data. Okay. If it is the shortest possible distance between L1 and L2, it means L1 and L2 are skew lines. And I hope you know what skew lines means in 3D. They are non-parallel and non-intersecting lines are called skew lines. Okay. And skew lines are well possible in 3D, not possible in 2D, but possible in 3D. Okay. Now we have to let M and N be variable points on L1 and L2 respectively. So, okay, one more thing is that your A will belong to L1 from here, and B will belong to L2. Why? Because we have to let AB is the shortest possible distance between two given lines. So we can take it like that. Okay, A is belonging to L1 and B is belonging to L2. So now after that we have to let Mn are variable points on L1 and L2 respectively, and the volume of the tetrahedron ABMN remains constant. Then which of the following statements is true? Now the question, actually, if you actually bifurcate the question from this part, you will see your question is the locus of the midpoint of Mn. Okay, and some information which is related to it. So guys, for that, like, it's a long way still, but we have to do. So basically, first thing, I will analyze the question step by step, okay, and very slowly. So first thing is, from this, AB is perpendicular to both L1 and L2. And let's say that AB, that this distance AB, it is equal to D. Okay. And one more thing, that the volume of your tetrahedron ABMN, it is constant. So this is, I guess, on a broad scale, the information that is given to us. Okay. So first thing that we need to do for solving this problem is that we don't have any fixed coordinate system. Now, whatever it is, 2D or 3D, we need a coordinate system to solve. Okay. So for that, like, our goal would be to fix the coordinate system in such a way such that it gives us maximum amount of benefit. So for that, guys, I am changing the page here. What I am going to do is, I will introduce capital A as the origin of the 3D plane. Not 3D plane, I should say 3D space. And that's why B, it will be equal to 0, 0 and D, say. Okay, like, this is along the Z axis, or I should say it is 0, 0, D, right? So it is lying on the XY plane and D is somewhere in the Z axis. So basically you can understand it is somewhat skew. Okay, we can make the line skew in this way. Okay, and from here, actually, we are letting L1 be the x-axis through A. Okay, like this might seem a little boring that I am writing so much of statements and all, but believe me, this question is a bit complicated. Okay, so if I don't write, you won't get it inside your brains. Okay, so actually we can take L1, like not L1, I should say the direction vector for L1. You can write it as D1 if you want. This will become M00. Okay, and M is actually an arbitrary number we are taking on basis of capital M and capital N. I am taking small m and small n. So small m actually belongs to any real number. Okay, and now for L2, let, from our coordinate system actually we are referencing to that and writing let L2 pass through B and make angle, say theta, with the x-axis in the horizontal plane. This line is important. With the x-axis in the horizontal plane, like angle theta. Okay, we are taking these variables for a reason. You will know that quickly. So if we actually take this horizontal plane that we are talking about here, it is actually z equals to d. I hope now it's clear, the skew lines we are imagining. So from here actually the direction vector of L2 that we will get. Okay, now try to visualize. Like if this is your 3D coordinate system, this is y, this is x, and this is z, then basically if the angle is theta, say this is the xz plane, right? Say somewhat this ray that it is going from A to B, say this ray is like this. It is making an angle theta. So actually if we want to denote the direction vector of L2, then this will become cos theta comma sin theta. For x it is cos theta, for y it is sin theta, and for this it will be obviously 0 because it's in the z. It's in the horizontal plane z. So angle made, I mean the direction vector, not the direction vector. Wait, I should say direction cosine for z. It will be 0. Okay. So now if we want to take any point on L2, any point on L2, then the most basic form that we can imagine is this, a constant multiplied by this, the direction vector. Okay, like we already know that the form of a straight line is this. This is the vector form of a straight line. Okay, so the most basic thing that can happen is a constant here multiplied with this. So actually n cos theta comma n sin theta comma 0. Like I am trying to take the most basic case that is possible. Okay. Okay, so guys, now after this, actually we have our data sort of ready. So now we are going to concentrate on our tetrahedron. So if we actually try to evaluate the volume of the tetrahedron, then it is pretty simple, like exactly what you have learnt in your theory. It is the STP, scalar triple product. So now question is for which vectors. So our tetrahedron was ABMN. So the vectors will be MA vector dot with your NA vector cross with BA vector. Okay. Okay, I actually wrote this in the A dot B cross C form. Okay, wait. Don't put third brackets. Just put a mod. Okay. Actually, I wrote the form that I should have written later. This is actually your scalar triple product. MA vector, NA vector, and BA vector. Yeah. So now guys, actually if we want to calculate this, first thing is we have to determine these vectors. So MA vector is very simply M comma 0 comma 0. Okay, like one thing that you want can actually note here is this direction vector actually simplifies the point M. Like direction vector is some constant, right? Some constant multiplied by this, right? Lambda 1 or something like that. And the vector that we have, like it's a vector plus lambda 1, a constant, times the direction vector. So that vector in the beginning which we have to sum, it's basically a point, and that point is the origin of the 3D space. And now that one constant that we need here, I'm taking it as 1. So M00. Like it's all assumption based thing, okay? Like see, main thing that we have to do is, if you see our options there, you will see nothing, no conditions are actually given, only about the asymptotes and whether the midpoint, whatever the midpoint is coming out to be, the name of that conic. So guys, after this, if we actually want to find out NA vector, okay, NA. So if we look at our NA vector, then from here actually NA vector will come out to be N cos theta, N sin theta, and one more thing, this will be D this time because it's NA vector. Okay, and your BA vector, I guess it's very simple. BA vector will be 0 0 D. So if we now actually evaluate this, the cross product NA cross BA, this will be IJK, and N cos theta, N sin theta, and this will be, I guess, D, and this is 0 0 D. So if you evaluate this, this will come out to be MND sin theta. Okay, I hope it is pretty easy to evaluate. Okay guys, so let's proceed. So now after this, our volume will finally come out to be 1 by 6 times of, let's put a mod because we don't know the signs of M, not specifically Mn, especially sine theta. Okay, so better to put a mod. So this is your final expression for the volume. Now our target is not still achieved. Our target was to find out the midpoint of Mn. So for that guys, I am actually like one thing, because volume of ABMN, there was a very important line in this question. Volume of ABMN is constant. So if this thing is a constant, then sine theta, we can't say anything about that, but Mn is a constant, right? So what I am actually doing is I am taking Mn, this product, to be equal to some constant k. So our M would be equal to k by n. This would come out to be of great use later on, you will understand. Okay, so guys, if we want to find out P, which is the midpoint of Mn, and very well established, like our M, actually if you see, MA point is only the M vector, or you can say M point. You can say M vector also if you want. This is the M vector and this is your N vector. Or you can say M vector N vector, or you can say M point N point, whatever you wish. Okay. So guys, if we find out the midpoint of Mn, actually this would come out to be like, I will write this in a point form only, okay? So M plus N cos theta whole divided by 2, N sin theta whole divided by 2, and small d whole divided by 2. Okay. So guys, after this, like we have the midpoint, but putting this into an equation and finding out the conic is seeming little bit impossible. So for that actually we have a solution. What I am doing is I am assuming capital X, like we will write capital X, capital Y, capital Z like that. Okay. So k by n plus n cos theta, and one more thing. Wait, let me write first. capital Y is equal to n sine theta by 2, and now you can see what I have done. I have substituted in place of capital M, I'm sorry, small m, k by n, okay, and this will be capital K. And that's actually, we got everything in terms of a single variable. That is why actually this thing was important. Okay, now listen. Basically, the thing is that this question is a very beautifully framed question in a way, because t by 2 is fixed. And that actually gives us a very important conclusion about this question. And the conclusion is that a midpoint, like whatever the locus is, will always lie on a fixed plane halfway in between L1 and L2. Okay. And don't worry, I will try to draw this out in a diagram after we finish some manipulation, because at the end actually to bring the final result I would have to teach you something. Okay, basically I don't think you will know this, but this is actually a very underrated topic in your syllabus, which is not mentioned in various books from like pair of straight lines. Like not a very underrated topic actually. You will find this topic, but thing is you guys miss this a lot in where in that part where you learn second degree equations. There this is mentioned, but still I will teach it, because from this question you will understand how important it is. Okay. Okay guys, so without further ado, let's manipulate this. So actually what I'm trying to do is I will write capital X as equal to k by n, and not only n. From here I will write n as 2 capital Y by sine theta and substitute it into capital X. So this will come out to be k divided by 2 capital Y by sine theta plus of your n cos theta. So 2 capital Y by sine theta times of cosine theta, and this thing is whole divided by your 2. So if you evaluate this a little bit, capital X will come out to be equal to k sine theta by 4y, and this thing will become y cosine theta whole divided by sine theta. Okay. Okay guys, so wait a minute, I will change the page. Now actually after this particular step we are very close to our answer, but now what you should think after this step, okay, I will tell you that. So basically don't try to do anything with those sine cos, because if you see, theta is something that we had taken as an arbitrary variable. So what we are going to do is we will frame a second degree equation from here and then study that second degree equation to find out the nature of our curve. Okay, so to frame that actually I will multiply this entire equation with y. So this will become xy is equal to k sine theta by 4 plus capital Y square cosine theta by sine theta. So if we rearrange the terms a little bit, then our second degree equation finally would come out to be cosine theta y square minus capital X capital Y sine theta plus of k sine squared theta by 4 is equal to 0. And this was capital K. Now, from here, actually, I have to teach you something. Okay, like not teach, you can say make you remember something. So guys, you have learned a very important thing in your coordinate geometry, which is a second degree equation. And a second degree equation is not a second degree equation if it doesn't contain these three terms. In addition to these three terms, there can be anything, but these three terms have to be present. Otherwise, it is not a second degree equation. Okay. And now actually, the condition, there is a condition, rather three conditions to determine which, like on the basis of coefficients, we can determine from a second degree equation to which conic it represents. So if you know this, very good. If you don't know, then please note this down somewhere. Okay. Like if b square minus ac is less than 0, then it is an ellipse. If your b square minus ac is equal to 0, it is a parabola. And if your b square minus ac is greater than 0, then it is a hyperbola. This is an important concept that we are going to use here. Okay. Now, I have actually developed another crazy method to make you explain this, because if you know, there is a small topic in our matrices known as eigenvalues. Now, eigenvalues is something that recently JEE Mains had excluded, but I don't think that it is in the not in the reach rather of our JEE syllabus. Okay, because JEE Advanced can anytime give you a comprehension type question mentioning what eigenvalues are, and then you would have absolutely nothing to do, because eigenvalues are something that you are studying and you aren't studying. Like, you have learned characteristic equations which are given in your NCRT, so you are actually learning the basics of eigenvalues and not learning. Okay, so I actually developed a crazy method to explain this thing to you using eigenvalues. So look carefully. If we write this equation, which is q of x comma y, as your ax square plus 2bxy, there is a 2 here, plus cy square is equal to 0. Okay, not 0, just q of x comma y is equal to this. Okay, so this particular thing describes two intersecting lines, straight lines rather. And now, what are these two straight lines? These are the asymptotes of the conic. And this definition is like very important. Okay, I will mark this in a different color. This definition that I wrote here, please, like, if you remember, very good, otherwise just write this down somewhere. This is a very important definition, okay, specifically for this sum if you want to understand. And now, actually, if we want to represent this using eigenvalues, what I will do is I will package these quadratic coefficients present here into a symmetric matrix. Now see what I am doing. Basically, q of x comma y can be written as equal to, in this case, x y, like it's not xy, it's a matrix. Wait, I will write this a little bit clearly by changing the page. Okay, so q of x comma y, this thing will be equal to x y, one matrix, a b b c, another matrix, and x y. Now this thing is actually the final form. Now if you can remember this form, very good, otherwise at least try to understand this. Okay, I think this concept is coming in your near future. This is where actually, like, you can find a relation between two very unexpected chapters, your conic sections and your matrices. Now see, if eigenvalues of this matrix equation, now I will write the conditions from where you can determine which it is. Okay, have, let me change the color to something different. Let's say golden, because golden amount of information, so golden. If they have same sign, then it's an ellipse. If they have opposite sign, then it is a hyperbola. And if they are 0, like basically not R0, okay. Just write this as one eigenvalue. Any one eigenvalue, if it is 0, then this will become parabola. And now what do these mean? These mean mod m is equal to 0. This means mod m is less than 0. And this particular thing means mod m is greater than 0. Okay. I hope this was a good learning experience to you. Like this is awaiting in the near future. Okay. If you want, then write this down. And I hope you have learned something from this part also. Because this actually explained the entire question and the motive behind it. Okay. So guys, now if we return to our question, so you will see from here we can find out the coefficients. So capital A is actually equal to 0 because there is no capital X square in our equation here. Okay. Capital B here is minus half sine theta. And your capital C is cosine theta. So if we calculate the discriminant of this equation, delta, which is equal to B square, or no need to actually calculate discriminant, directly calculate your B square minus AC. Then it will come out to be equal to your sine square theta. Okay, sine squared theta, which is obviously positive. So if it is positive, then hyperbola is your answer. Okay, so our curve will be a hyperbola. So now let's actually see the question once again, okay, because question is not still ended, there is something else. Okay, so actually if you see, our option A and B are both hyperbola. Now there is one additional condition also, that hyperbola, the asymptotes are parallel to L1 and L2 and not parallel to L1 and L2. So I guess we need to study the asymptotes also. So let's do that. Okay, so guys, actually to study our asymptotes, what I'm going to do is, this is very normally done. I will ignore the constant term which we had in that quadratic equation, okay, the one we found. So if we ignore that, actually cosine theta y square minus of sine theta xy, because they are actually asymptotes, okay, so we can ignore the that constant term, and this will be equal to 0. Like don't ignore the constant term in your normal equation, okay, I am calculating asymptotes here, that's why I can ignore. Please be careful, okay. Anyways, y times of cosine theta y, this can be written as y times of cosine theta y minus of sine theta x is equal to 0. So your asymptotes are y equal to 0 and I guess y equals to tan theta times x. So these will be your asymptotes. Okay. And guys, now I will draw a rough diagram which maybe can help you out. Let me see what I can draw. Okay. Okay. So guys, this is our diagram. I don't know how clearly depictable and visible this is. I tried my best to draw it. Like if you see, this is our line number L1 and this is our line number L2, and I have color coded also, like this will be L1 here and this will be L2 here. This is the tetrahedron, okay, tetrahedron. I tried to draw it, like it's very difficult to draw tetrahedrons on a 2D plane, but still this is a tetrahedron, and you can see this is the P midpoint which is lying in between the midpoint of M and N, which is lying in between L1 and L2, which are two skew lines, and this thing is the plane Z equals to D by 2 on which this hyperbola is lying. Now the hyperbola is not obviously accurate, I just wanted to depict the shape, so I have drawn like that. So maybe guys, this will be some sort of an approximate diagram, and now actually we can find out the answer. So actually if we go back a little bit, here's our two asymptotes we found, and if you see, this thing is perfectly parallel to L1 because L1 was itself x-axis, okay, rather not parallel, I should say it's absolutely over L1, okay. And if you go into this, it's y equals to tan theta times x, and we took L2 passing through B and making an angle theta with the horizontal x-axis. So the slopes are perfectly same, which means it is parallel to L2 also. Okay. So guys, I guess if we look into our options once. So in option number A, locus of midpoint of MN is a hyperbola whose asymptotes are parallel to L1 and L2. This will be the correct answer for this question. Option number A. Okay. So that's it guys, and I will once show you the amount of working we did. So it's actually a huge deal. Like a lot of this question was not even like to solve. Okay, you could learn a lot of things, I hope, from this question. Anyways guys, this will be the end of today, and I will be back again with the next video. So if you have liked my content, please do like, share and subscribe. And any doubts, anything else if you want to say, feel free to ask me in the comment section. And that's it for today guys. Thanks for watching.